Hi guys, in this video we're going to look at the definition of a hyperbola, and then we're going to see how to come up with the general formula for a hyperbola from the definition of a hyperbola. And of course the general formula is going to be this for a hyperbola centered at the origin, and of course here we're saying that b squared is basically equals to c squared minus a squared. Now, what is the definition of a hyperbola? Well, to understand the definition of a hyperbola, we start with our description of an ellipse. Let me just remind you what we said about an ellipse. For an ellipse like this, centered at the origin, if we take our descriptions, of course we said if this is at 0, 0, we take the vertices here to be at minus a, meaning a distance a from the origin, and the one at the right side here, this is going to be at positive a. Of course this is along the x-axis, and then on the y-axis, basically the y-axis passes somewhere here. Okay, so this is what we have. Then we have the two fixed points, in this case the foci. So this is f1 and this is f2. Now, to define an ellipse, we sought to say it's going to be a set of all points in a plane whose distance, the sum of the distance from two fixed points, will always be the same. So from here to there, if this is a point on an ellipse, the distance here between P and F1 plus the distance from that point to F2, that distance must always be the same. If it's the same with all the other points, then those points are going to be forming this ellipse. In other words, we can have another point here, the distance from here to there, plus the distance from here to here, has to be the same as what we got earlier on, and this distance from here to there, plus the distance from here to here, has to be the same with the first two we found. In the same way, the distance from here to here, plus the distance from here to there, has to be the same as the sum that has to be the same as what we found earlier on. So all such points which will satisfy that condition will form that ellipse. Now, to define what a hyperbola, we want to base, or it's kind of similar to our definition of an ellipse. But how do they differ? Well, firstly, an ellipse, a hyperbola I mean, kind of opens in this way. So if you have a hyperbola like this one, now it's more like you have two parabolas that are facing away from each other. So you have this, and then this, of course, let's take the most basic one, centered at the origin. Okay, so in this case, if you have a hyperbola centered at the origin at 0, 0, so of course let's define a few terms. The distance from the center of the hyperbola to the vertices, that is just going to be a on each side. Since you're going to the left, this will be minus a. To here, this is going to be positive a. And then the fixed points here, the foci, so this is f1. Of course, being on the x-axis, this has to be minus c, 0. Don't forget, the distance from the center to where the focus is c. And then going this side, this will have to be going to positive c. So this will be c, 0. Now the definition of a hyperbola. Well, for a hyperbola, we're saying it's a set of all points in a plane such that the distance from that point to a fixed point, the first fixed point, which is the first focus, minus the distance from the same point to the second focus, the difference will have to be a constant. So such points whose difference will always give you the same thing will be forming what we're calling as a hyperbola. So if this gives you some difference, and when we go to a second point that is here, and then again we have to go to the second focus. Now if it falls on the same hyperbola, it should reduce to the same constant. Now the constant we expect to actually find is going to be 2a. So in other words, we're saying the distance from P to F1 minus the distance from P to F2. This distance will always be equal to a constant, and that constant is actually 2a, which is the distance between the two vertices. Now, from this skeleton of a formula, we can actually now generalize or obtain the general formula. Now, how does it work? We start with first getting what these distances are. Let's get first Pf1. So here, the point P, we generalize this and say, okay, let's say this is a random point, x, y. So it implies that from P to F1, the distance will have to be, I can say x minus, then the value here, this is minus c, so it becomes minus minus, which is plus c, then squared. Here, of course, I could have easily said minus c minus x. Because of the square that comes here, the minus minus will easily be squared out to reduce it to just a positive version. Then we have plus the y values, it's y minus 0, which is just y, and then we'll square it. So this is what Pf1 is. Now we move on to Pf2. What do we get? For Pf2, from P to F2, F2 is here. So this is going to be x minus c, y minus 0. So you have x minus c squared plus y minus 0, just y squared. So when we substitute into our formula, the difference between these two has to be equal to a constant. So what will be that difference? So the difference will be root x plus c squared plus y squared, then minus root x minus c squared plus y squared. This has to be equal to a constant. Remember that constant, 2a. Move the second radical to the right hand side. I want to eliminate the square roots here, and to do that, we'll keep the first radical. We'll move the second one to the right. Okay, now we can square both sides. When you square the left, you eliminate that square root, you remain with x plus c. On the right side, this becomes 4a squared. This becomes, the next part will be plus, and then this will be 4a, then there's the radical. And of course, for the last term there, the square root will just disappear, and this will be plus x minus c squared plus y squared. So here I was just expanding this squared and this square. So this is what reduces to this term that we have there. When we look at this equation, this squared and this, of course, these are going to subtract out. We remain with this squared, the x plus c squared, and this is going to be x squared plus 2xc plus c squared. On the right side, however, this will still be 4a squared, this will still be 4a, then you have root x minus c squared plus y squared, but that last term, the x minus c squared, can be expanded, and it gives us x squared minus 2xc, then plus c squared. Again, we see that c squared will also subtract out. So you now have x squared. Oh yeah, x squared will also subtract out, because we see x squared appears here. It also appears there. So that will subtract out. So the 2xc and minus 2xc there will combine, they will add up. We get 4xc. Then the other side we have 4a squared plus 4a. Then we have root x minus c squared plus y squared. So just make sure you don't make mistakes here. It's easy for you to make mistakes, especially when you're doing this a little bit fast in an exam room. At this point, the 4 can cancel throughout, it's common in each term. So you have xc a squared plus a root x minus c squared plus y squared. Now we can just leave the radical on one side, one to come in square. So this becomes xc minus a squared is equal to a root x minus c squared plus y squared. At this point, we can eliminate the a by dividing through by a there, and what we'll have is xc over a minus a squared over a will just be a, and this will remain root x minus c squared plus y squared. Now we can square both sides, or if we want, we can actually combine this into a single fraction. If we did that, this would be xc minus a squared over a equal to root x minus c squared plus y squared. We can square both sides now, and if we did, would have xc minus a squared over a squared. Okay, I'm saying that I've squared the a down here. Let me remove that and say I'm squaring everything here. The right side, the square root disappears, and we remain with just this. At this point, we can expand these expressions. The top part becomes x squared c squared, and then this will be minus 2 a squared cx, then plus a to the power 4. All this is over a squared. The right side will have x squared minus, so the next part will be 2 cx, then plus c squared, then plus just still be y squared. If I multiply through by a squared, just eliminate this, we get x squared c squared minus 2a squared cx plus a to the power 4. Then the right side now multiply by that a squared, so that we have a squared x squared minus 2a squared cx plus c squared, that's a squared c squared, and you have plus a squared y squared. So at this point, do we have terms that can simplify here? Well, yeah, you observe that this term here is the same as this term here, so those two, and they have the same sign, so they'll subtract out, leaving us with x squared c squared plus a to the power 4 is equal to a to the power 2 x squared plus, that is a squared c squared plus a squared y squared. Okay, so at this point now, group everything that has an x or a y on the left side, and group them of course accordingly. So I have x squared c squared here, and then I also have this has an a squared, it has an x there. Then I'll get the one with a y, so y comes here minus a squared y squared. Then everything else goes to the right. We already had a squared c squared on the right, but then the minus a to the power 4 joins. So from this term, I can now easily say x squared, so I can factor out x squared here. I have c squared minus a squared, and then what will remain, the x squared goes out, then minus a squared y squared. And when I look at these, I can also factor out a squared from these terms, so I'll have a squared here, and what will remain there is just c squared minus a squared. So at this point, so we're now going towards the final part. So at this point, divide everything by the right hand side. So I factorize the right hand side, that's easy for you to see what will happen. So just get this now and divide through by the right hand side. So if I divide everything by a squared, c squared minus a squared, same here, same here. Notice that for the first term, c squared minus a squared will cancel out. What we remain with is just x squared over a squared. On the second term, what will cancel is actually just a squared. So what will remain is y squared over c squared minus a squared. On the right hand side, well, it's the same thing, so you only remain with a 1 there. Now we are almost done. You see this term here, the c squared minus a squared, this is what we now define as b squared. So say but b squared is equals to c squared minus a squared. Therefore, the general formula becomes x squared over a squared minus y squared over b squared is equals to 1. So this becomes the general formula for a hyperbola that is centered at the origin. But what if it wasn't centered at the origin? What if it was centered somewhere else, at a general point, let's say h, k? Well, if you remember the general formula for one centered at the origin, you just have to modify it a little bit. If your hyperbola is now centered, so if your hyperbola is now centered at h, k, it implies that the general formula will now be x minus h, of course this is squared, over a squared minus y minus k squared over b squared is equals to 1. So this is now what becomes of your hyperbola. Now notice that we derived our formula, which is this one, for a hyperbola that was more like this. So it had its measure in the x-axis. What if you had one whose measure was in the y-axis? What would change? Well, what controls that if you're looking at the general formula? If this is what you had, the only thing that would change is that now you have y squared here, and then the difference is that now the minus will be with x squared. So this is what you will end up having. So you can actually even say, so for this one, since A is a measure from the central point to where the vertices are, so you can actually say that now A is playing with the y-axis, or is in the vertical, and so B comes here. So this is now what we're going to have. So the minus now is with an x. So if I was given something like maybe x, let's say I can even say x squared over maybe 9, and then I have minus y squared over maybe let's say 25, and this is equals to negative 1. So for something like this, I know to say the right hand side has to be a positive 1, so I would multiply everything by negative 1, which would make negative x squared over 9 plus y squared over 25 is equals to 1. So now I can clearly see that what I'm seeing is this is equals to 1. So clearly this is a hyperbola whose measure is in the y-axis. So I'm looking at a hyperbola that is more like this. This is more like this. And because by looking at the formula there that we're given, clearly this is centered at the origin. This is what we're looking at here. So of course, figure out what A is. The positive one, positive A, and somewhere here we'll have minus A. And then of course, we can bring in a few more key terms like the asymptote of the hyperbola, and so on. So here we're just trying to define the hyperbola. So in the next class, we're going to do more questions where we actually demonstrate how we use the formula for a hyperbola. Now guys, hope you found this helpful. See you in the next class.